Off yesterday in lesson 3.6. We did example A here, right? And luckily the BenQ did not erase overnight, so I still have example A up there. We're going to try example B. Okay? Now I will say my morning class thought example B was a teeny bit easier. Partially because I knew what they were doing, but partially because there's part of it that works out a little bit easier. So let's go through the process. Step 1 was to find our PRRs, possible rational roots. Now, that was going to be factors of what over what? Okay, factors of the constant, which is negative 10. So factors of negative 10 over factors of the lead coefficient, which is 1. So factors of negative 10, goodness, over factors of 1. What are my factors of 10? Okay. 10 is 1 times 10 or 2 times 5, right? Denominator, what are factors of 1? Just 1, right? Plus or minus 1. So, nice part is we have a nice easy list of PRRs here. When you put them each over 1, you're going to have plus or minus 1, plus or minus 2, plus or minus 5, and plus or minus 10. And those are the PRRs, right? Okay. Now, what's step 2? Okay. Step 2 is we're going to hop on Desmos, and we're going to check our PRRs on Desmos. Okay, so that's typing your graph into Desmos and checking to see where your graph does what? Right, where does it cross the x-axis? Hopefully at some combination of 1 plus or minus 1, 2, 5, and 10, right? Now, believe, nope, there we go. Okay, I had mine graphed from previously. X cubed minus 2x squared plus 5x minus 10 shows that we know for sure it crosses where?
2.
At 2. Any place else? No. And if you think about it, my PRRs, the highest and lowest, were 10 and negative 10. Can I see my whole graph from 10 to negative 10? I can, and I don't see anything else, right? So that means there is going to be one rational PRR that's going to work. There's going to be one. That means I'm going to be having to find how many more?
2.
2 more, right? If this is x to the third, we need a total of 3 answers. One answer is going to be 2. We need to find the other 2. And since we can't see them, you know they're going to be imaginary? Okay. So let me go back to my notes here. So when we check on Desmos, we found, oops, we're going to try x equals 2. I say try. I mean, we know 2 works at this point. It was pretty obvious in the graph, but I say try because, you know, sometimes it's not as obvious. So, step 3. We're going to take 2 and do what with it?
Synthetic division.
Synthetic division. So 2 in the box. 1, negative 2, 5, negative 10 beside it. And do your synthetic division, right? Those numbers were came from my problem. Drop the 1. 2 times 1 is 2. Add. Negative 2 plus 2 is 0. Multiply. 2 times 0 is 0. Add, 5 plus 0 is 5. Multiply, 2 times 5 is 10. Add, negative 10 plus 10 is 0. We at least got the synthetic division, right? Okay, now, good news. There is a remainder of 0, yes? Because there's a remainder of 0, that means 2 worked, as we expected. Now, while I'm here, let's talk about factors real quick. What is 2 expressed as a factor? That would be representative of x minus 2, yes? What's my other factor right now? What does 105 represent? X squared plus 5? Because this was originally x cubed, so this is now x squared. So x squared plus 0x, I don't need to write plus 0x, and then plus 5. Now, x squared plus 5, is that going to factor anymore? It's not going to factor anymore. I know that because I don't have any more PRRs to work with here. I had one viewing on the graph, and that was it. Since I don't have any others to work for, this isn't going to factor anymore. So if you are asked for a factored form, I think they would want you to stop right here as far as I know. So this is your factored form. Okay, because x squared plus 5 doesn't factor anymore. It's going to have imaginary roots. Okay. And step 4. Maybe. To be honest, I'm not going to use quadratic formula on this one. But it's solve and find our zeros, right? Okay. One of our factors, which we already know this one. One of our factors was x minus 2. The other factor was x squared plus 5. And so if we set each part equal to 0, and I don't know why I wrote them next to each other there, but if I set x minus 2 equal to 0, we already know we have a solution of 2. We've already decided that, right? It was a PRR, it was on the graph, done deal. My other solutions come from x squared plus 5. Now, yesterday, on the previous example, we had to use quadratic formula. We did not have a choice in the matter because there was x squared plus bx plus c. Now, could you use quadratic formula here? You can. However, I think it's overkill. How can I solve, since there's no bx term, how can I solve x squared plus 5? Can we subtract the 5 over? And this only works because there's no bx term, okay? So x squared equals negative 5. How do I solve from there? Square root, yes? That's old news. Square root of x squared is x. Square root of negative 5. Okay. Plus or minus, because we're in that equation setting. The square root of the negative gets pulled out as an I. The square root of 5 is not a perfect square, so we're going to leave it a square root of 5. So plus or minus I square root of 5. How many answers do I have? 3. We have the 2, and we have positive I square root of 5 and negative I square root of 5. So we have 3 answers. How many answers was I supposed to have? 3. Okay. As long as we're finding our imaginaries also, you need 3 full answers of some sort there. Is that maybe a little bit better than where we left off yesterday? A little? I don't know. Seemed a little less confusing today, but okay, guys. Something to work at, right? Probably the hardest part of the lesson, I would guess. Ready to talk about the backside? Now, the backside, I think the concept behind it is easier. However, it's very tedious. You have to be very careful with what you're doing. Okay? As long as you don't make careless mistakes, it'll be a piece of cake. But, guys, I left lots of space, right? And when I leave lots of space, that usually means there's work to go with it. Okay? So, you know, we have to work at these, but they are doable. Okay, so what we're going to be doing is we're going to be writing the functions down here with the information they give us. But before I go into that, okay, conjugate root theorems. If a polynomial has either irrational roots or imaginary roots, then those roots will occur in pairs. I've already talked about that, haven't I? The fact that plus or minus I, that was a pair, right? Plus or minus I square root of 5, that was a pair of roots. Okay, or plus or minus just square root of 5, that's a pair. So anytime you have either an irrational with a square root, basically, or imaginary, so when we talk irrational, I'm thinking square roots. When I talk imaginary, I'm talking i's, they're going to occur in pairs. And that's good information that we have to know here. Now, for instance, if a plus square root of b is a root, then a minus square root of b is also a root. They are what we call conjugates. I don't know if I've used that word this year in this class or not. Maybe just in pre-calc, but they're conjugates in that they have the same pieces, but the sign in the middle is opposite. So if a plus square root of b is a root, so is a minus square root of b a root. Same thing is true for imaginaries. And this is a typo. This is supposed to say a plus bi. If a plus bi is a root, then a minus bi is a root. Keep the a and the bi the same, just change the sign in the middle. Okay, keep that thought in mind. Let's look at example 1, or example A. What is a quadratic equation in standard form with rational coefficients that has a root of 5 plus 4i? Okay, quadratic. What do we mean quadratic equation? What's an example of a quadratic? What's the highest power in a quadratic? Not 4. What kind of equation does like the quadratic formula solve? X to the second. Okay, so I know we want to think 4. 4 is quartic. But so a quadratic equation is going to be x squared. So my highest power is going to be x squared. And that means there's officially how many solutions or roots? 2. Okay. Now, they want it in standard form, which just means we're going to have to multiply it all out, and we have to go powers highest to lowest. Rational coefficients. I'm not going to have a square roots. I'm not going to have any i's. And it has a root of 5 plus 4i. How many roots am I supposed to have here? 2. Because this is a quadratic. That's x squared. I need 2 roots. They only gave me 1. What do we know?
It's 5 plus 4i. It's also 5 minus.
Okay. There you go, guys. So we're going to use the roots of 5 plus 4i and 5 minus 4i. They will do that all the time. They'll give you 1, and they'll expect you to just automatically notice, oh, I got to throw in the other one. I got to throw in its pair. Okay, so beware. Now, this is going to be putting it into factors. And so, for instance, if this was a root of 5, what does 5 look like as a factor? It's x minus 5. Okay, but I'm not using just 5, am I? It's 5 plus 4i. So it's going to be x minus, and then I put the parentheses, the quantity, 5 plus 4i. Now I'm doing that on purpose. I'll explain. So it's x minus the root of 5 plus 4i. And what's my other one? X minus the root of 5 minus 4i. I did that because you're subtracting, like on that first one, you're subtracting both the 5 and the 4i. And so if you just write x minus 5 plus 4i without the parentheses, you're not going to have the right signs. Now, if I remove these inner parentheses, x minus, and if I basically distribute this minus sign, it's going to be minus 5 and minus 4i. If in the other one I also remove the extra parentheses, distribute my minus, it's x minus 5 and plus 4i. So if you can go ahead and go straight to the line I have written right now, that's fine. But this is just the idea of doing x minus the root. Now, this represents our quadratic equation. Standard form means this has to be multiplied out. So big old FOIL, if you will, distributive property. I'm going to start by taking this x right here and multiplying it by what? Everything in the other parenthesis. So x times x is x squared. X times minus 5, minus 5x. X times 4i. Just think of that I as kind of like another variable. And x times 4i, I'm going to say plus 4ix. Now, repeat the process with the next term. So the negative 5 here in the middle. Distribute it to all three pieces. Negative 5 times x minus 5x. Negative 5 times negative 5 plus 25. Negative 5 times 4i minus 20i. And you know what I'm going to say next, right? Now take the negative 4i and distribute it. Negative 4i times x minus 4ix. Minus 4i times minus 5 plus 20i. And minus 4i times plus 4i. Minus 16i squared. We just multiplied a trinomial times a trinomial, right? A 3 by a 3. If you multiply a 3 by a 3, you should at this point have 9 terms. Now, are we done? No, there's some very nice cleanup that will happen. First of all, the whole thing is it says rational coefficients. You should not have any i's left when we get done. The i's are all going to cancel out. Is that happening? 4ix will cancel with minus 4ix, right? Minus 20i cancels with positive 20i. What else do we have that needs to change? Yeah, negative 16i squared. There's no plus 16i squared to cancel with it, but what do you guys remember about I squared? I squared is negative 1, right? And a negative 16 times a negative 1 is going to become instead a plus 16. Does that sound familiar? Okay. Final line. I have an x squared, right? Minus 5x adds to minus 5x, which is minus 10x. Plus 25 adds to plus 16, which is plus 41. Okay, guys. There's your first example. There's a lot to it, but you just have to be careful, right? As long as you don't make careless little mistakes, it's a piece of cake. However, there's a lot of room for mistakes, isn't there? So be very careful. Take your time, watch your signs, multiply carefully, so on and so forth. Questions? Okay, well, I'm ready to try part B. Sorry, it talks about function Q in there. I was thinking ahead. Okay, part B, you ready? Part B, what is a polynomial function Q of degree 4 with rational coefficients such that 2 minus square root of 3 and 5i are roots? Okay, well, information to point out. What's degree 4 mean? When I get done, my first term is going to be x to the 4th, right? So this means there's going to be an x to the 4th here. And how many roots do I have to get started with? I'm supposed to have 4, right? How many did they give me? 2. That's a problem, isn't it? Okay. What do we know about 2 minus square root of 3? Yeah, the conjugate. There's also a 2 plus square root of 3. Okay. What do we know about 5i? What'd you say it was? Yeah, a minus 5i. Okay. I mean, you can think of that being a 0 plus 5i. So the conjugate of 0 plus 5i is 0 minus 5i. Obviously, we don't need to write the zeros. So we have the minus or negative 5i. Now do I have 4 roots to start with? Now we have 4 to start with. Okay, let's write them out. Okay, 2 minus square root of 3. So it's going to be x minus 2 minus square root of 3. I'm choosing to put the extra parentheses in right now. If you can mentally skip that step and get it right, that's fine. We're also going to have x minus the 2 plus square root of 3. And an x minus 5i. And I'm officially going to say an x minus negative 5i. But what do you know about a minus negative 5i? It's going to be plus 5i, right? It is important that you write the like pieces next to each other, because in another step here, when we go to multiply, you'll want to have the like pieces next to each other. But I'm going to clean this up. The first one, x minus the 2 minus square root of 3, I'm going to write as x minus 2 and plus square root of 3. The next one, that was x minus the 2 plus square root of 3, x minus 2 and minus square root of 3. X minus 5i is fine as is. And x minus negative 5i is actually x plus 5i. Okay, this is where the big work comes into play. Because we have how many parentheses? We have 4. So you're going to have to multiply 2, and then multiply those answers together. It is important to make this the nicest possible problem we can, that when you multiply the pieces together, you're multiplying the conjugates with each other. So you're multiplying the 2 square root of 3 parentheses with each other as a pair, and you're multiplying the 5i's together as a pair. Okay, that is important. So, you ready to multiply? I'm not sure if I'm going to write all the arrows in, but I'm going to take the x first and multiply it by each of the 3 items in the next parenthesis. So x times x is x squared. X times minus 2, minus 2x. X times minus square root of 3. You can write that as minus square root of 3x if you want. Just make sure your x doesn't go under the radical. Or minus x square root of 3. Now we're going to distribute the negative 2. Negative 2 times x, negative 2x. Negative 2 times negative 2, plus 4. Negative 2 times negative square root of 3, plus 2 square root of 3. And then distribute the square root of 3. Square root of 3 times x plus square root of 3x. Square root of 3 times negative 2 minus 2 square root of 3. And square root of 3 times negative square root of 3. Okay. Negative square root of 9. Okay. That was our 3 by 3 that we just multiplied and got 9, yes? Now, my recommendation before we go and clean that up, you may have already forgotten, don't forget, what else do we have here? We have the 5 i's, don't we? Don't get so far ahead that you forget to go back and multiply those. So I'm going to go ahead and multiply those now. X times x, x squared. X times 5i is plus 5ix. Minus 5i times x is minus 5ix. And minus 5i times plus 5i, minus 25i squared. Okay, some cleanup happening. If I've not made mistakes, first of all, in this first one, there weren't i's in here, but all the radicals should cancel out or simplify. Okay, so radicals should all be gone because we are only going to have rational coefficients, and i's should all be gone. So minus square root of 3x cancels with plus square root of 3x. Plus 2 square root of 3 cancels with minus 2 square root of 3. What do you know about the square root of 9? I can't cancel it, but the square root of 9 is 3, yes? So that is actually going to be a minus 3 instead. Okay, let's clean that up, see what I have. I've got an x squared out front. Minus 2x and minus 2x is going to be minus 4x. And plus 4 goes with minus 3. 4 minus 3 is plus 1. Still amazes me when that cleans up so nicely. Clean up this other one too, right? 5ix minus 5ix will cancel. What do we know about 25i squared? Yeah, I squared is negative 1. And so that's going to become, instead of minus 25i squared, plus 25. And so I'm going to have x squared plus 25. Am I done? No. Now we have a 3 by 2 to multiply. If I multiply a 3 by 2, that means I'm going to have 6 terms to then clean up, which will probably go down to 3 terms. Nope, never mind, it doesn't. Actually, this one's not going to clean up very much after we multiply it. Okay, ready to multiply? Everything in one parenthesis multiplies by everything in the other parenthesis, right? So I'm going to start with this x squared in the first parenthesis. X squared times x squared in the other parenthesis is x to the fourth. X squared times 25 is 25x squared. Okay, now I'm going to distribute minus 4x. Minus 4x times x squared minus 4x cubed minus 4x times 25 minus 100x, and then distribute the 1. 1 times x squared is 1x squared. 1 times 25 is plus 25. Okay. Clean it up. I know there's only one x to the fourth term. Standard form is the name of the game. So put them in order. After x to the fourth, I need x cubed, which I only see minus 4x cubed. Here it is. 25x squared plus 1x squared, though, is going to be 26x squared minus 100x plus 25. So that one didn't actually clean up very much after all. Okay. I have one more example planned, and I set this one up the way some of them in homework are set up because I didn't want you to be thrown off by how they asked this question. Form a polynomial f of x with real coefficients having the given degree and zeros. So degree 4 means it's going to be x to the fourth, and we should have 4 solutions, right? 4 sets of parentheses to multiply. Now, zeros. 3 minus 5i and negative 1 multiplicity 2. Okay, well, somehow we need to make 4 out of that. What's the obvious one to you? Yeah, if there's a 3 minus 5i, then we know there's going to need to be a 3 plus 5i. Now, do you understand what they mean by negative 1 multiplicity of 2? We talked about multiplicity back somewhere. Lesson 3.5 maybe? If it's a multiplicity of 2, basically it's just saying it occurs twice. Okay? There's going to be 2 of the same parentheses. Because remember, multiplicity is the power on the parentheses. And so it's saying there's going to be 2 in the same parenthesis. Okay? So if there's 2 of the same parentheses, does that give me 4 sets? Yeah. 3 minus 5i, 3 plus 5i, negative 1, and then negative 1 again. Okay, let's set it up. Three minus 5i is going to be x minus the quantity. 3 minus 5i. 3 plus 5i, x minus the quantity. 3 plus 5i. Negative 1, how do we express that? Most of you guys are going to probably tell me, oh, if it's negative 1, I'm going to say x plus 1, right? Or x minus negative 1. And then multiplicity of 2 says I have 2 of the exact same parentheses. That's what multiplicity of 2 says. If it was multiplicity of 3, we'd have a third parenthesis. Multiplicity of 4, we'd have 4 of the same parentheses. Okay, let me clean it up and then we can start multiplying out. The first one, x minus the 3 minus 5i, is x minus 3 plus 5i. X minus the 3 plus 5i is x minus 3 minus 5i. And you may have already written this one differently. X minus negative 1 is really just x plus 1. And x plus 1 a second time. And now we are ready to multiply. Okay, distribute. Remember what I said last time. You need to put like pieces together. Okay, so we need to multiply the 3 and 5i parentheses together, and then the others together. That's going to be your easiest chance of success. Okay. Take my x and distribute. X times x. X squared. X times minus 3. Minus 3x. X times minus 5i. Minus 5ix. Then distribute the negative 3. Negative 3 times x. Minus 3x. Minus 3 times minus 3. Plus 9. Minus 3 times minus 5i. Plus 15i. Now I'm distributing 5i. 5i times x. 5ix. 5i times negative 3. Minus 15i. 5i times minus 5i. Minus 25i squared. Should be 9 terms there, right? Because I just multiplied a 3 by 3. Your choice, now or later. Don't forget to multiply x plus 1 times x plus 1, right? So don't go too far. You will forget. So if we multiply this one, x times x, x squared, x times 1, 1x. Then distribute my 1. 1 times x, 1x. 1 times 1 is 1. Okay, clean up. Should be some i's canceling out. Don't just assume. Make sure it legitimately happens. Minus 5x and plus 5i. Excuse me. Minus 5ix cancels with plus 5ix. 15i minus 15i are gone. Minus 25i squared. It's really going to be plus 25, isn't it? Because I squared is negative 1. Okay. Let's see. What do we have here? X squared minus 3x goes with minus 3x, which is minus 6x. 9 goes with 25. 9 and 25 is 34. Okay. Other parenthesis, x squared plus 2x plus 1 is 1x plus 1x. Am I done? Nope. One more time, guys. One more time, and we're there. This is again multiplying a 3 by 3, so you should have 9 once you multiply them out. This is giving you lots of practice of multiplying today. X squared times x squared. X to the 4th. X squared times 2x. 2x to the 3rd. X squared times 1. 1x squared. Now I'm going to distribute negative 6x. Negative 6x times x squared. Minus 6x cubed. Negative 6x times 2x. Minus 12x squared. Minus 6x times 1. Minus 6x. And then I'm multiplying by 34. 34 x squared. 34 times 2x is going to be 68x, and 34 times 1 is going to be 34. Okay. what do we have here? X to the fourth stands alone. 2x cubed minus 6x cubed. 2 minus 6 is going to be minus 4x cubed. X squared. X squared minus 12x squared plus 34x squared. 1 minus 12 is negative 11 plus 34 should be 23x squared minus 6x plus 68x, so plus 62x plus 34. Okay, guys. Your homework is 3.6 in Solvis due tomorrow. Okay? This is very doable. You just have to be careful. Okay? Take your time. Be careful. And make sure you are getting those signs and numbers correct.